was finishing up grad school, I was very excited to learn that there was a postdoc opening in the Planetary Defense Group at Livermore, and I jumped at that opportunity. I was so excited to do more of that interdisciplinary work, working as part of a team, trying to solve really tough multi-physics problems.
So I came to the lab 3 years ago, actually, from Los Alamos, where I was a postdoc and a member of the scientific staff. And I came in to be a part of the ignition campaign on the NEF, which has been a very exciting 3 years to be here.
My career at the laboratory started in 2011. I was a postdoc for my first 3 years. In those first 3 years, I developed foam materials for the National Ignition Facility.
I really got excited about fusion energy is what really started my interest in this area, and it's what we do in the ICF program. I remember being in college with in a nuclear engineering class talking about fusion, and they posed the question of how do you hold something that's 1,000,000 degrees? And it's like, wow, that's how do you do that?
Well, when I was a kid, I started surfing in my early teens, and what I'd spend a lot of time doing is looking at weather maps and trying to understand, when the waves were going to be and how the waves were going to be. And that then led me to really spend a lot of time focusing on weather maps and generating a real appreciation for the weather and then climate.
One thing I'm most proud of is what we've been working on recently with the device assessment framework, which is a modeling framework that we're using for forensics and other applications. And that has been really exciting because, well, we're borrowing a lot of code that we wrote, or things we wrote for previous modeling frameworks. In a lot of ways, we're building it from scratch. And that has been both exciting and also daunting.
And I think where we're going to next is trying to better understand some things like, for example, tipping points, going beyond just quantifying the absolute number of change, but trying to better quantify what those changes will be into the future.
There's no extra credit for doing it all on your own. You really want to drive to a solution as fast as possible. There's a lot of urgency to national security problems, and so not feeling like you need to figure out everything by yourself is something that changes a lot probably for most people when they come out of grad school and come to an environment like this, where you want to use all the resources that you possibly can to solve these difficult problems.
I think the main thing that's helped me is just to persevere and keep working. The challenges can seem daunting, but particularly as part of a team like we do at the lab, lean on your colleagues and get through it together.
What I'm looking at right now, which has been interesting, is I mentioned the device assessment framework. We're really digging in on the validation in, I think, ways that I haven't really done before, which has been really interesting. And looking at how do different model settings impact the results and understanding where is the best, especially with emergency response, speed matters, but you cannot, if you completely sacrifice your accuracy for speed, then you're not useful.
Scientific research, to me, is just asking questions and just digging in and trying to find answers. And I think for young people, I think that's natural. And sometimes that gets driven out of them. But if it doesn't, I think they'll eventually become a scientist. And so hopefully my advice to younger people would be just to keep asking questions and never stop.
So if I were going to talk to a young person about science, I would tell them that science is the building block of all the information moving forward into the next generations. I would say if we don't understand the things that happen on a small molecule size, if we don't understand how they couple those materials into functionality, how they affect the future performance, how they affect the lives that we live, then we really can inform how to build the next great thing.
Well, I started off as an intern back in grad school and had such a great experience that I decided to joined the lab full-time just a few years later, and one of the best decisions I ever made. Since then, I've had a chance to work on diagnostics for the National Ignition Facility, being able to deploy real hardware that's being used even today to help monitor and keep the NIF pulse shaping system intact and in a safe operating regime.
My favorite project for the last 3 years, I've been leading this project to develop an entirely new global atmosphere model, a general circulation model, which is designed to work on exascale computers and also to be of an order of magnitude finer resolution than we've ever seen before. And so that's it's really cool, the things we're able to do with it. The projects come together really well. It's just about done now. In the next month or so, we should be starting our simulations.
I think for me personally, the biggest challenges that I've faced are just more trying to figure out how to most effectively work in a very big team. Like all the experiments that we do involve very large numbers of people doing computational design, and the physicists doing the experiments, and teams building the samples that we need to use, and teams running the facility, the experimental facility where we have to do our experiments. And all of these groups need to be able to work effectively together.
Well, I mean, this is something I've said a billion times before, but one of the most useful places to network for me personally was the lab daycare. So I actually, I know it's not like a usual piece of wisdom, but as many opportunities you have to make the casual connections, such as things you'll find in the lab daycare or employee resource groups, or just any other sort of avenues for social connection, those are what will wind up helping you over and over and over during the course of your career. So that would be my advice, is to pursue outside interests in addition to pursuing your job.
Both tackling a challenging problem, struggling with it for a while, and finding a solution, but also doing that as an individual, but also working with a broad set of teams, you know, running into walls that you can't climb over yourself, and having a colleague, someone you're mentoring or a mentor, you know, push you in the right direction, or helping other people go in the right direction, and tackling those problems together while the entire team advances their own knowledge is sort of what keeps me going.
Well, for me, it's somewhat personal. I think a lot of people at this lab probably have a similar opinion. I really wanted to do mission-oriented science. That was, I mean, I'm very interested in basic science, but I came to Livermore because I wanted to be part of supporting U.S. government and its interest and in its science. That was a big deal to me. It comes with a lot of responsibility, but wow, the things that you can do as part of a national lab are pretty unlike anywhere else in the public sector. That's why we exist. So yeah, for me it wasn't serving a national mission was a big part of the appeal.